So I'll now attempt to draw the free body diagram of M1. There is a inclined plane whose angle theta is known. There is a mass M1, and we have to worry about the external forces on M1. Now there is a force which is acting perpendicular to the inclined plane, which is called the normal force, and this is the force of the inclined plane on the mass m. There is no force which is along the inclined plane because there is no friction. Now this floor can only push, it cannot pull, and therefore we know the direction of the normal force, though we don't know the magnitude. Now there is only one other force on this object, which is the pull of the gravity of the earth, which is equal to mg. So that ends the free body diagram of this object. Now I'll just redraw here the other important information, that is the coordinate system. Now in the last slide we said that we're going to use a coordinate system that is fixed to the inclined plane, and that is perfectly acceptable. So now I'm going to just redraw the diagram along with the coordinate system. So I have this as my x-axis, this as my y-axis, and I have one force along the y-axis which I'm calling as n, and another force. Now this is the interesting part of the problem. There is another force which is in the downward direction, and that is equal to mg. And let me quickly mark the most important aspect of this problem, a little bit of geometry, which is that if the inclined plane angle is given as theta, then theta plus this angle is 90, but this force or y-axis being normal to the inclined plane, this angle plus this angle is also 90, and we quickly reach the conclusion that this is theta. This is going to be important when we are going to do the resolution of this force mg.